Hi guys, it's week 10, so we are looking at lessons 103, 104, and 105. So 3 lessons to get through this week. So we're starting at lesson 103, and the concept we're covering today is the perimeter of complex shapes. So again, maybe a polygon with a semicircle, or could be 5, 6, 7, 8-sided shape that we need to break apart into polygons and shapes that we're used to working with. So if we look at this one right here, it's important to know this sentence right here in the book: assume that corners that look square are, again, if this is 89 degrees and this one is 91 degrees or something, then this gets all thrown off. And there's still a way we could do it. It's just going to get a lot more complicated. So even though they don't have all the right angle indicated with the little 90-degree symbol, we can assume that they are. Because if it wasn't, then these rules wouldn't apply. But since they are all square, then we know they're all 90 degrees. So we can apply some properties. So like this length down here being 7 centimeters, well, I know this distance from here to here has to also be 7 centimeters. So B, whatever that is, plus 3 has to add up to 7. Okay, so even though this one's higher than this one, I know still from this side to this side, no matter where I go, is 7 centimeters. Okay, same thing here. This is 6, so I know this plus this have to add up to 6 as well. So that can help us find our missing sides. If we didn't have that, or they weren't right angles in the corners, then this side may be slightly longer than this, but they are all right angles, so we can apply these properties. Okay, well, 4 plus 3 equals 7. 4 plus 2 equals 6. Then we can just add them all up. 3 plus 6 plus 7 plus 4 plus 4 plus 2 is 26 centimeters. And it's still perimeter, so it's just our units: inches, centimeters, feet, miles, whatever. It's not squared. So if we look at this one right here, let me see if I can get it drawn decently. Oh, not a circle. Trying to white that out so it looks okay. It's not as well drawn as in the book. I just don't want us to think that that's a side, because then we're going to try and add it. So 8, 4, 2, and 10, and these are all in inches. And N and M. Take a look. 4, 10, 2. Okay, so we have 2 missing side lengths. Again, perimeter, when it's a polygon and all the sides are straight, then we know we just add up all the sides. When we start adding in circles, then we have to deal with circumference, which we've done that before, but it looks like all the ones today are going to be polygons. And this is 1, 2, 3, 4, 5, 6. So this is a hexagon. It's not a regular hexagon of what we're used to seeing, but it still is. So we're going to add up all 6 sides. First, we need to find N and M. Well, this is 2, this is 8, so I know the difference has to be this number right here. So that's going to be 6. Okay, M plus 4 have to add up to 10, so I know this is going to be 6 as well. Okay, so we have to use those properties. Well, from this side to this side, no matter where I do it, is going to be 10. So we use that to find those missing sides. Now we just add up 8 plus 4 plus 6 plus 6 plus 2 plus 10. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Got them all. So 18, 24, 26, 36. And then it was in inches. So we want to include that. So again, just find your missing side lengths and then add up all the sides. So we've been working with perimeters since the beginning of the year. Not too difficult. We just have to, apply what we know about parallel sides and shapes that have right angles to find missing side lengths and then add up those side lengths to the ones that were given. Only 2 on the practice set, so we'll go over that when we get to class. 14 is algebraic addition, and they have, I think this is the one. Yeah, they have a big long sign game with it, and we may come to this. I think, we can take a look at it. We obviously can't play it by the video, so we may be able to do it in class, but we're thinking about pairs of positive and negative charges become neutral. After determining the neutral pairs, we count the signs that remain and then write our answer. There are 4 skill levels to the game. Be sure to be successful at 1 level to move on. So plus and minus cancel out, plus and minus, and I'm left with 2 positives. And so you're just basically counting up, positives, canceling them out with negatives to make them neutral, and then going on. So again, if we think, this is kind of a long roundabout way to get you guys thinking about adding and subtracting positive and negative numbers. So if I have positive 3 or just 3, again, sometimes the book, they put in that plus sign with it, which is fine for now, but down the road, we're just going to want to put positive numbers without any sign, because if there's no sign, we know they're positive. But for this to emphasize that it's a positive number, that's fine. So 3 minus 2 minus 5 plus 1. Okay, so we combine our positive numbers and our negative numbers. And then if we did 4 plus signs and 7 negative signs, we would have we'd have 3 negative signs left, or negative 3. So again, this isn't a way I recommend to go about, because if we had negative 53 plus 100 or something like that, playing this game, drawing out all of those and then calculating, you're going to spend a very long time to just do what, as you get more practice, will become a pretty simple concept. But adding or subtracting, again, we got to think about the number line. So let's kind of veer off of that and do our own. So again, the book sometimes will do like this, which I don't love, because the parentheses and the plus sign. Then if we do in our calculator and we start adding the plus sign for positive numbers, we'll get an error message. So let's just call it 5. And then if I do minus 3, something like that, we know that's simple. Again, 5 minus 3 is 2. But then if I rearrange this and I have negative 3 plus 5, okay, well, if I had negative 3 negative signs and 5 positive signs, I'd have 2 positive signs left over, so it would be positive 2. So again, this way it looks much easier because we've been doing this since probably elementary school, kindergarten. Okay, but we rearrange negative 3 plus 5, it still works out to be positive 2. So you can think about kind of your number line. So again, the number line may help you. Your first kind of starting out with these, you don't have to do it. And eventually down the road, like I said, if you're doing negative 125 plus 250 or something like that, if you draw out that number line to negative 125 and then 250 spaces to the right of that, you're going to spend forever just drawing out your number line versus doing the calculation. So what did we have? We had negative 3 plus 5. So if I start at negative 3, okay, and then I'm adding 5, so that positive 5 means I'm going to the right. And I'm going to the right 5 times. So 1, 2, 3, 4, 5. So that's where we end up. So I think the number line starting out there may be a little bit more helpful. Again, the game, if you guys want to kind of on your own go through, don't write in the book, obviously, but just kind of mentally go through or copy it on a piece of paper. That's fine if it's going to help you kind of get used to positive and negative numbers. Again, we'll be mostly working with integers. Again, whole numbers and their opposites. Those are our integers, but we can, have negative fractions. We can have negative decimals. We can have negative irrational numbers. There's a lot of different things that we can do with negative numbers. So this is kind of the first introduction to it. Thinking about our signs. So I always remember that if it's, and this applies for when we get into multiplying and dividing negative numbers, but if we have two negative signs, a negative and a negative make a positive. If we have one negative sign, one is an odd number, so one negative sign, one negative sign, one negative sign, one negative sign, that makes it negative. So if we have obviously two positive signs, it's positive, but if we have one negative, then it's negative. If we have two negatives, it's positive. Three negatives, that'd be more for multiplication, but three negatives would be negative. Four negatives would be positive, and it's going to follow that same odd and even pattern into infinity. And we're probably not going to see five negative signs between numbers because that just wouldn't make sense unless we're multiplying five negative numbers in a row, which we're not going to see any of that today. But just be aware of that. Again, I would just write it as 3 because what happens, so let's think of an example here and I can show you in the calculator what I mean. Let's say negative 3 minus, and the book may have it something like this. So negative 3 minus positive 4. I would just write it as negative 3 minus 4. Okay? But if you do this, and we can do this in the calculator, I'll show you. So it was negative 3 minus 4. So if we go over here to our calculator, now negative 3 minus positive 4, so a couple things on the calculator, at least the TI-84. If we're making a number negative, use this symbol down here right by the decimal. So this little negative sign in the parentheses, we want to use that. So it was negative 3 minus 4. So negative 3 on the number line, and we're going 4 more to the left. That's going to put us at negative 7. Okay? But if we do negative 3 minus and then use this plus symbol to indicate that it's a positive number, our calculator is going to get an error off of this because it's basically performing contradictory computations. It can't do that. So we're going to get an error message. That doesn't mean it's not possible. It's just, oh yeah, we don't need or even really want that plus sign in there. It's negative 3 minus 7. Now we can do negative 3 plus negative 7. Okay, that's the same thing. Adding a negative is the same as subtracting its opposite. So minus 7 or plus negative 7 would be the same thing. But again, the distinguish, don't make positive numbers positive with the plus sign. Just make them positive by entering them in. Negative signs, again, if we're making a number negative, we're using this one. If we're subtracting, we're using this one. So let's go back to the example we just did. If we did negative 3 and then we did plus, and then we forgot to do this for negative 7, we did plus negative 7. It's the same thing as up here. When we have minus and plus next to each other, we got an error message. We're going to get an error message for that as well. So, I remember negative 3 plus negative 7. So just be aware of that because, again, we may get something where it's like an easy example. 5 minus 5 we know is 0, but if we do 5 and then use this for subtraction, accidentally 5 minus 5, well, how is 5 minus 5 negative 25? Well, what the calculator is thinking is 5 and then a number next to it means multiplication. So 5 times negative 5 is negative 25. So that's where just make sure you're putting things in correctly into your calculator. Again, I don't love when they do that. I think they just want to hammer home that this number is negative and this one is positive, this one is negative, this one is positive, but it's we don't need it. So when you see me write it on the board or things like that, I won't include usually the parentheses or positive sign for positive number. If we're adding something, then yeah, we'll do the positive number. So again, all these different levels, and then that actually takes us to the practice set. So we'll do these together. If you want to practice with them, we can do it in our calculator. We just got to be careful, like these are going to throw us off, or those symbols, and we don't need the parentheses. Again, they're just trying to indicate this integer is positive and this one is negative. But my preference is obviously less is more, so I'm not going to put in the parentheses because we don't need them. We're not performing an operation in the parentheses, and definitely not going to say plus 2. It's just plus 2. Okay. So we'll go over those in class. And then our last lesson we're looking at, make sure it hasn't booted. Yeah, okay, we're still in. Good. Okay, using proportions to solve percent problems. So again, proportion, we're just comparing two numbers. A percent, we're comparing two numbers. 30 for every 100, 30%. We can write it as 0.3. 30%, 30 over 100, which would reduce down to 3/10. So let's take a look at this. 30% of the cars in the parade are antique cars. 12 vehicles are antique cars. How many vehicles are in the parade in all? We're just going to set up. We just actually did this. I don't remember which lesson, but when we're setting up, similar to when we do our ratio and our actual count, it's going to be the same kind of concept, the same procedures when we're doing this. It's just instead of a ratio, the ratio we are using is a percent. So we have 30% antiques to non-antiques, and then total. Okay. All of our parts of a whole we know always add up to 100%. So we can fill that one in even if we're not given that number. 30% of them were antiques. 70% were not antiques then, because you're either an antique or you're not. So we weren't given that number, but we can fill it in. So again, ratio, but in this one it's a percent. So that's percent actual. And then 12 of them were antiques, and we want to know total number of cars down here. So let's say 30 to 100. And we can reduce that to 3 over 10 if we want. We don't need to. It's going to work out the same way as 12 over x, or a, b, c, whatever you're calling it. So these ones are in the numerator. These ones are in the denominator, so they lined up. Cross multiply and divide. Three goes into 12 4 times, so 3 goes into 120 40 times. And so, and again, like I said on the previous ratio, when you're comparing boys to girls in class or whatever, in this example, you can just look at your number. 30% was 12, so 40 total cars. That sounds, just in looking at it, that it makes sense. And if we got a really large number, like we did 1,200 divided by 3 instead of 30, and we got 400 cars or something, that looks a little too big. That doesn't really make sense. Oh, we just forgot a 0. If we got a decimal or a fraction in this example, that wouldn't make sense. So we'd want to go back and check our work. Okay, so they set it up. Antiques. Again, we can flip actual count and percent. That doesn't matter. We just need to make sure that they're lined up and in the proper column and row because that's what we build our ratio off of, and then we cross multiply and divide. Only 40% of the team members played in the game. If 24 team members did not play, how many did not play? Okay, so it's just first set up what we know. Play, did not play, the acronym for did not play, and then total, percent actual. So we're told 40% of the team members played. The total team is 100%, we know. So 40 played, so that tells us 60%, sorry, 40% played, so that tells us 60% did not play. If 24 team members did not play, then how many did play? So we want to know this right there. So we had to fill in the 60. We found that the difference between 140 is 60. If 40% played, then 60% did not play. You either played or you didn't. Okay, so we set this up 40 to 60. We could reduce it to 4/6 or 2/3. You don't need to. If you want to make the multiplication easier, if you're doing it by hand or something, it may help you out. Okay, so 40 to 60 equals P to 24. 60P equals, this was 960. So cross multiply and divide. It's the same thing. So P equals 960 divided by 60 is 16. And then we could add those up to figure out the total number of players. I don't think we were asked to find that. So if we needed to, 16 plus 24 is 40. So that's our total team. And so same thing, it's just like our ratios. Now when we added in the total, same thing for percent, our total, all the parts added up is equal 100%. So that makes it easy because we can fill that in instantly. We're given one of the 2% that we're comparing, fill it in, and the difference will tell you the other one. Fill in your actual counts, whatever you're given, and then figure out what you're given and what you're trying to find. Set up your ratios and cross multiply and divide. Buying shoes on sale, Nathan paid $45.60, which was 60% of the full price. What was the full price of? So this is kind of similar to one we'll see even a little bit further down the road, but we have, actually I won't show you that way. We can set it up as original is 100% and then the change, what the sale price was, or whether it went up or down or whatever, but we'll just do it how we've been doing. So what are we comparing? So he paid $45, which was the 60%. So this is going to line up with 60%. So the full price is 100, and paid discounts, original or total or original price. So we have percent, and then this one is money. So he paid 60% of the original, which was 100. So if it's 60% of the original, that's 40% off or 40% discount. He paid 45.6, and we want to know the full price, the original price, or what he paid, what he would have paid full price down here. So 60 to 100 equals 45.60 to X. Make sure these lined up. Cross multiply. If we remember, multiplying by 100 means we're moving the decimal place 2 places to the right. So we could go in and calculate it, or maybe save a few steps, move it 1, 2 places, because I'm multiplying by 100. There's 2 zeros. And then we divide. X equals 4560. Oops. Oh, what is going on? 4,560 divided by 60 equals 76. So the original, let's go back to our problem and make sure this makes sense. So the original price, the full price was $76. Back then it's 40% off or 60% of the original, and it was $45.60 is what he paid. Yeah, that number looks like it makes sense. But this is an example where obviously we don't have to have whole numbers because you're not paying 44, 45, 46. You can pay $45.60. So if we got something with a decimal here, even though we didn't, if we did, for this example, it would have made sense. So just always, check your work. I have some students even, in the older grades that they try and jump ahead. They've done so many times, they want to just, get straight to calculating the answer, which I understand. You want to save time. But I would always write in what you're given, make sure it's lined up properly, and then set up your ratios to cross multiply and divide. And sometimes you mix up these numbers or these numbers, and you can throw yourself off. So again, speed is not the goal. Doing it correctly is the goal. I think that was, 106 we'll do next week. So be looking for that. We'll see you guys in class.